I can find the area of a polygon. Now in this video, I'm going to walk you through the steps on how to find the area of this hexagon here. Again, when we do this, we do have to know that the polygon is regular, so that's going to be important. And then again, the main idea I need you to understand for your test is that we do not have a formula for this polygon. So we do have to break it down into smaller shapes that we do have the formulas for, and we have been using triangles. So we're going to break this hexagon down into triangles that we can find the area for, and then add up all of the pieces from there. So the first step is to find the central angle. So I'm going to divide up this hexagon into its central angle, so by connecting the center to each vertex. Again, the central angle, so all 6 of these angles, 1, 2, 3, 4, 5, 6, are going to add up to 360. So to find each central angle, I'm going to do 360 divided by 6, and that's going to give me 60 degrees. So this angle here is 60 degrees. Now, again, just to back up, we are finding the area of this triangle here, so I'll kind of highlight it to help. We want to find the area of this triangle right here. So to do that, the area of a triangle is 1/2 base times height. That is a formula you will need to know for your test. So once I found my central angle, I'm going to add my height. I'm going to add that in. Just make a note that your height bisects this top angle, and it bisects the side, and it's perpendicular. So it's going to cut the side in half. So each of these pieces are going to be 1 inch, and it's going to cut this angle in half. So that's why step 2 is find half of the central angle. So 60 degrees divided by 2 gives me 30. So I'm going to pull out just one of these triangles within this shape here. So again, this is now 30 degrees. We took 60, cut it in half, so it's just this side of the triangle. The 2 inches, it becomes a midpoint because it cuts this side in half. So this side's going to be 1 inch, and this is going to be my height. So step 3 is going to use trig to solve for the height. Now you could use Pythagorean theorem, you could use all these things, but because we only have one side, we have to use a trig ratio. So the side across from my reference angle is the opposite side, the side across from my right angle is the hypotenuse, and then that leaves the adjacent side. So using SOHCAHTOA, we can figure out which trig function it is we need to use. So opposite and adjacent is going to be tangent, which is t, and then that's O over A. So tangent of 30 degrees equals opposite, which is 1 over hypotenuse, or excuse me, adjacent, which we're labeling as h. That's not hypotenuse, that's my variable for the adjacent side. So to solve for this, I'm going to cross multiply. So tangent 30 degrees times h equals 1 times 1 is 1. To get h by itself, I need to divide by the tangent of 30 on both sides. So in my calculator, I am typing in 1 divided by the tangent of 30, and that is going to give me 1.73. So that is the height of my triangle. So step 4 is to find the area of the triangle. So again, the area of this highlighted triangle is 1/2 base times height. Well, my base we were given was 2, this entire distance, and then we just found the height to be 1.73. So when I do that, I multiply that out. That gives me actually 1.73 inches squared for my area. So step 5 is then to find the area of the hexagon. So I found the area of this triangle here. And remember, these are all congruent isosceles triangles. These are, this is a regular hexagon, so all of these sides are congruent. So I don't just have one of these triangles, I have 6 of them. So that last step is going to be to multiply by 6 because I've got 6 of these triangles, and that will give me a final area of 10.39 inches squared. Again, there's a lot going on in that problem, but the main idea is that we had to break it down into a smaller triangle and find that area first.